Hello, everyone. My name is David Brown. I am the co-founder and COO of Helix Carbon, where we are building proprietary electrolyzer systems for the iron and steel industry. And what we can do is take in waste streams directly off of a furnace and convert them right back into the useful syngas to be used on site. This not only deals with emissions, but can displace fossil fuels and even triple margins for an iron maker. And we're building strategic connections. We're looking for our next pilot. We have a pilot agreement in place, which we'll get to, but we're looking for more pilots, bigger pilots, revenue-generating pilots, anything to validate to you, the customer, that we can do what we say we can do. At the same time, we're also looking for collaborations in the lab. We're open to research collaborations, and of course, we're fundraising. So, we're targeting iron and steel because steel is 10% of global CO2 emissions. 2/3 of that, about 2 gigatons, comes from the iron reduction step alone. So just turning iron ore into iron that's ready for steel making. And the reason why is syngas. That's synthesis gas, a mixture of carbon monoxide and hydrogen that comes from fossil fuels, which means when it's made, it emits carbon dioxide. And this gas is pumped into a furnace at very high temperatures. Iron ore is sent in over the top, and as they pass over each other, a reduction process happens, and out the top comes carbon dioxide, which means in both its production and its use, syngas is emitting carbon dioxide. And there is no way around this. There's no replacement, not at the hundreds of furnaces in operation today. There have been attempts to try and skirt around this problem. Scrap EAF, some of you are probably familiar with the concept of a mini mill, an electric arc furnace. It's a cleaner way to make steel, but that doesn't so much solve the problem as it just uses less iron, and you're limited by scrap quality and the amount of scrap anyway. There's direct oxide electrolysis, Despondé spin out, Boston Metal, if you've heard of them. Very cool technology. It's going to take a really long time for them to scale. Very excited for when it gets there, but it's going to be a very long time. Hydrogen DRI has the most backing currently, but it faces a problem, and it's the same problem they all face. They need new plants. And if you're an iron maker with billions of dollars of assets deployed, with potentially 50 years of life left on them, they haven't paid themselves off, you're not going to abandon those plants just to lower your emissions, and then also spend billions more on new plants. It doesn't make any sense. What you need is a solution that can go on site where you're at today. And that is what Helix Carbon is building. A proprietary electrolyzer system can co-electrolyze carbon dioxide and water at the same time to create a syngas mixture. And we can do it out of dilute and dirty waste streams, such as the waste streams at an iron furnace. And so we can take in the waste directly, no carbon capture required, turn it right back into the exact same syngas that's already being used today, controlling emissions and displacing fossil fuels. And we've already proven the ability to do this at industry-relevant lifetimes. So if we look at the state of the art, other folks who are trying to utilize CO2 out of dilute waste streams, their systems last, on average, about 15 hours. We've gone out to 400, actually even longer now, but this chart only goes out to 200 hours. And to be fair, we have not hit end of life. We actually just only have one test stand, and we need to do more tests on it, hence the fundraise. But we've been able to prove intermittency as well. And this is a key piece. Iron makers are very risk averse, and they want to know that they can get the lowest cost of delivered gas, and they want to know that their system is going to last. The intermittency piece is significant because the price of electricity, specifically green electricity, fluctuates throughout the day. Our system can turn on and off very easily. So when electricity is green and cheap, around noon, you can turn our system on and you've got the cheapest, cleanest syngas you can possibly have. When it gets expensive, you can turn our system right back off and go back to using fossil fuels. Hydrogen electrolyzers cannot do this. The cheap ones can anyway. Already, we're beating hydrogen on price And at the price that we've been quoted for renewable energy, we've seen it get down in some geographies to as low as 10 to 20 megawatt hour, $10 to $20 per megawatt hour. At that price, we're even competitive with fossil fuels. And for the iron producer, this is a great revenue play. It gives them access to green steel markets from their current assets. And these green steel markets have been proven to sell for big premiums, 30 to 40%. There are millions of megaton contracts currently outstanding across the world that simply cannot be filled by the world's green steel capabilities today. On top of that, in the US, you've got 45Q and 45V carrots that can add to your revenue. And of course, in Europe, you have the CBAM and ETS, the sticks that you want to avoid. We see hardware sales for our systems to be a nearly $400 billion market, starting in the United States and then expanding globally. Outside of that, though, perhaps more importantly, over a gigaton of CO2 abated every single year. And those are massive numbers, but we have the right mix of experience, technical expertise, and operational knowledge to get this done. Evan is our tech-focused CEO. He's got a background in chemistry. He was also a consultant and actually advised the Biden administration on policy that is now the IRA, specifically on decarbonizing the steel industry in the United States. I'm a former U.S. Army officer and Apache helicopter pilot, so I know how to make an operation happen from beginning to end. Dr. Ariel First is an MIT professor, and Dr. Michael Smith is our first employee, and he is a PhD electrochemist in CO2 electro reduction from Princeton. Now, I said we've already got a pilot agreement in place for our first 10 kilowatt scale pilot. We are looking for an industrial player for a 100 kilowatt scale pilot and beyond as we move to the market. In addition, we've already closed about 10% of our pre-seed round, and we are closing in on a lead to fill out the rest of it. If you'd like to join us, please talk with me after, and we can close the carbon cycle together. Thank you.